Hi again. So today we have sort of practical class. So we solve a couple of problems about initial value problem for the string equation. So the string equation utt minus uxx equals 0 on the whole line u of x0 equals f of x, ut of x0 equal g of x. So this is our initial value problem, and what I want what I'm going to do now, I would like to consider some simple example. No, we considered already very simple examples. Now examples of different nature. So we have a general formula u of xt equals 1/2 f of x plus t plus f of x minus t plus 1/2 integral from x minus t to x plus t g of y dy. So consider the first problem, rather simple. Suppose we have the following thing: f of x is identically 0, g of x equals the following. It is 1 when module x less than or equal than 1, 0 when module x more than 1. So this is the function, this sort of function, yeah, x, it is g of x. What does it mean to substitute this into equation as the initial condition, and what is the meaning of this is another interesting story which I will tell you next week. And now we consider just the application of this formula to see how it looks. Physically, it is the following. We have this infinite string, and we say give it a kick, say by some say plain slab, which simply strikes the string along the segment from -1 to 1, and then we have some evolution of this string. It is what can happen even in some musical instruments. So no wonder that it is interesting. So in this case, only the second term remains. The first term is 0. So u of xt equals integral from x minus t to x plus t g of y dy. And let me write it in the form equals g of x plus t minus g of x minus t, where g of x is a primitive function of g of x dx. Yes? Now in this case, if the function has this form, then g of x equals the following. First we integrate from -1 to x when x is less than -1. This is naturally 0. Then we integrate here, so it is 0, x less than -1. Now here it is equals to x plus 1 if -1 less or equal than x less or equal 1. So we integrate this 1, and then at the point 1 it is 2, so it is 2 x more or equal than 1. 1/2. Here is 1/2, of course. This formula. So this is g capital of x, the primitive function. And so we have to find g capital of x plus t minus g capital of x minus t. And here we can have two different situations. First case, when t between 0 and 1. So in this case, let us consider this situation. So g capital has this form. It is a linear function. It is 0, it is 1, it is 2, and then it is constant 2. Yes. So we have here two singular points, where points of discontinuity of derivative of the function g capital. So if you consider the picture, what is g of x plus t minus g of x minus t? One moment, let me draw it here. So it is g. So g of x plus t, if t positive, looks like this. One moment. It is like this. Yes. And here 0. G of x minus t looks like this. Yeah. So this is a point t minus 1, 1 minus t. 1 minus t, this point minus 1 minus t, this point 1 plus t, this minus 1 plus t. Yeah. So we have four singular points, two singular points for the first term and two for the second. So let us draw this picture. It is 0, 1, minus 1. So t between 0 and 1. So it is let me draw it as 1 plus t. This is 1 minus t. This minus 1 plus t, and this is point minus 1 minus t. So we have 4 singular points. Now it is clear that g1 plus g2, g of x plus t minus g of x minus t, here it is 0, because both terms is 0. Here it is 0 because both g of x plus t and g x minus t equal 2, so the difference is 0. And so we have 1, 2, 3 interesting segments. Yes. So now let us write down the equation for G on all 3 of these segments. So G of x plus t minus G of x minus t. In fact, we have 5 segments, including this part and this tail. Yes, so it is 0 when x less than minus 1 minus t, less or equal. It is 0 when x more than 1 plus t. And here we have to see which part of this works. So when x between minus 1 minus t and minus 1 plus t, then this function g of x plus t already is non-zero, and g of x minus t is 0. So we have simply g of x plus t. So g of x plus t, it is x plus t plus 1. When minus 1 minus t less than x less than minus 1 plus t. So between this and this point. Now, when we are between minus 1 plus t and 1 minus t, both these terms work equally, so we have to write here g of x plus t, it is x plus t plus 1 minus g of x minus t minus x plus t minus 1. It is when minus 1 plus t less than x, then less than 1 minus t. Yes. No, okay, I will transform it. Now, when we are between 1 minus t and 1 plus t, then this term is already 2, because we are already here. And this term, the second term is given by this. So g of x plus t, it is 2, minus g of x minus t, minus x minus t minus 1, minus x minus t minus 1. It is when 1 minus t less than x less than 1 plus t, and 0 when x more than 1 plus t. Now we have here many excessive terms, so let me transform it a little. It is g of x plus t minus g of x minus t equals 0 when x less than minus 1 minus t, minus 1 minus t. Here it is x plus t plus 1 minus 1 minus t less than x less than minus 1 plus t. Next is this term goes x minus x. It is 2t. That's it. 2t. X minus x, t plus t, 1 minus 1. 2t minus 1 plus t less than x less than 1 minus t. No, okay. Now here 2 minus x plus t minus 1. 1, it is 1 minus x plus t. 1 minus x plus t 1 minus t less than x less than 1 plus t. And 0 x more than 1 plus t. Oh my god. Now we have to find, to draw the picture. To this end, we find the coordinates of the characteristic points. So for x, let me make a table. It is x, it is g, g of x plus t minus g of x minus t. So x is minus 1 minus t. The function is 0. Here x equals minus 1 minus t 1 minus t. 1 minus t. It is 1 minus 1 plus t. So minus 1 plus t plus again t plus 1. So it is 2t. 2t, t equals 2t. Now next point is 1 plus t. It is again 1 minus t, 2t. 1 plus t. 1 plus t, it is 1 plus t, 1 plus t minus 1, 0. Okay, so we have the following picture. Minus 1 minus 1 minus t, minus 1 plus t, 1, 1 minus t, 1 plus t. So here it is 0, here it is 2t, here it is 2t, here is again 0. Yes, and it is 1 minus t, minus 1 plus t. Okay, so let me draw several frames of the movie. So recall that u of xt equals g of 1/2 g of x plus t minus g of x minus t. Here is this, we have to divide it by 2. So first it was 0. Then we have the following. This is a point minus 1, this is point 1. This is 0. Then we see the following picture. The following picture. So first here the function grows because we gave a kick to the string, so the string moves up. On one hand, it moves up along this segment. The segment is from minus 1, one moment, it is not exactly so, this one. This one. So the segment, there is some central part of the segment which goes up with the unit speed, and at the same time it becomes shorter and shorter. Yes? On the other hand, here we see that this part propagates along the x-axis. So this inclined part here and here, first they eat the space beyond the segment where we gave this kick, and eats the space inside. Yes, so next we'll have something like this. This horizontal segment becomes shorter and shorter and higher, and at last at t equal 1 we have this picture. So what happens next? Next we have the following picture. It is even simpler. So g of x plus t minus g of x minus t, when t is more than 1. The picture is the following. G of x plus t is like this. This is the graph of the function g of x plus t. The function g of x minus t is here. Yeah, this is the function g of x minus t. This means that if you take 1/2 g of x plus t minus g of x minus t, then we have the following thing. These interesting parts where g is changing do not overlap. So it is, let me remind, g of x equals 0, x less than minus 1, x plus 1 if minus 1 less than x less than 1, to x more than 1. Yeah? So here it is equal 0, x less or equal minus t minus 1. Then it is x plus t plus 1 when x between minus t minus 1 minus t plus 1, then it is 2 between this and this point, minus t plus 1 less or equal than x less or equal than t minus 1. So this is point minus t, this point t. One moment, maybe I take a different pen, like this. And here it fades down. It is this difference, this works. It is 2 minus x minus t plus 1 when t minus 1 less than x, then t plus 1. And for x equal t plus 1, t plus 1, t, yes, and 0 when x more than t plus 1. Yes? So the graph will be clearly the following. Let me draw it here. This. So this is minus t, this is t, this is t plus 1, this is minus t minus 1. minus t plus 1. This is t minus 1. Yeah? And so now we can see, draw here the continuation of this movie. What happens next? It will be the following picture. It will be horizontal piece like this. And then this piece will elongate, the height will remain the same, it will be 1. I forgot to write here 1/2. 1. So this goes to the right, this goes to the left. So here is the full movie. What happens if you say give a kick to the string along some segment? Now after a long time it will look like this. You see how it looks. Okay. Let's consider still other example. Example, f of x equals x plus 1 minus 1 less than x less than 0, 1 minus x 0 less than x less than 1, 0 x more than 1, and 0 x less than minus 1. So this is this function. Here we have such a cap, and here it is 0. It is f, and g of x equals 0. So we have to find solution of the wave equation. In this case, u of xt equals 1/2 f of x plus t plus f x minus t. Simply so. And again, we have here two cases. Case 1, t between 0 and 1. So let me draw the diagram. What happens? F of x plus t is the same function shifted to the left by t. F of x minus t is the same function shifted to the right. So if t less than 1, so we have this configuration. It is f of x plus t, this point minus t, and this is f of x minus t, and this is this point is one moment. Let me draw it better, like this. Yeah? Yeah. This is t. It is f x minus t. So here we have to find the singular points, the points where the analytic expression of the function changes. So here we have this point, it is minus 1 minus t. It is this point is here we have minus 1, but it is not a singular point. This point is minus 1 plus t. It is this point. This point here, this changes. It is minus t. 0 is not a singular point. This is point t, point 1 minus t, and the point 1 plus t. Minus 1 is irrelevant here. Yes. Yeah, so we have 5 interesting points, and in each of these segments, one moment. Yeah. Yeah, no, situation is even more interesting, because the point minus t and minus 1 plus t can be in this relation, and if t less than 1/2, and it is can be opposite. First goes minus t and then minus 1 plus t when t is more than 1/2 but less than 1. Okay, let us take this order. So it is t 1/2. Yes. We have f x plus t. So we have the following intervals: minus x less than minus 1 minus t. Next, minus 1 minus t less than x less than minus 1 plus t. It is this. Minus 1 plus t less than x less than minus t. Minus t less than x less than t. T less than x less than 1 minus t. 1 minus t less than x less than 1 plus t. And x more than 1 plus t. And in each of these domains we have to write the function. So it is f of x plus t plus f of x minus t. Okay, here when x less than minus 1 minus t, both functions are 0. So here we have to write 0. What we write here? Here fx plus t is already positive. It is 1 minus x, just a minute, x plus 1. So it is x plus t plus 1. T plus 1. Here I have to look at this line. Here in this domain, the first is x plus t plus 1 plus the second is x minus t plus 1. X minus t plus 1. Yes? Because I have to write fx plus t plus fx minus t. Here, from minus t to t, here we have to take the first line x plus t plus 1, x plus t plus 1, plus x minus t plus 1. Now we will find it next. Here, between this and this, we have both are decreasing. So here we have x plus x, 1 minus x, 1 minus x minus t. One moment. Here, the first is decreasing. One moment. Let's do it again. Yes, so here just 1. Here both are increasing. X plus t plus 1 plus x minus t plus 1. Here the first is already decreasing. 1 minus x minus t plus, and here we have to write x plus t plus 1. X minus t plus 1. Here, where it is between minus t and t. Here both are decreasing. 1 minus x minus t plus 1 minus x plus t. Here only the decreasing part of the second is 1 minus x plus t. And here we have 0. So u of xt equals 0 when x less than minus 1 minus t. Here x plus t plus 1 minus 1 minus t less than x less than minus 1 plus t. Third, x plus t to x plus 2x plus 2 minus 1 plus t less than x less than minus t. Here one moment. Minus 1 plus x minus yes, the fourth, it is 1 minus x minus t plus x minus t, 2 minus 2t, 2 minus 2t, when minus t less than x less than t. Here 1 minus 2x, 2 minus 2x, 2 minus 2x, t less than x less than 1 minus t. Here 1 minus x plus t, 1 minus t less than x less than 1 plus t, and 0 x more than 1 plus t. Yeah, no, okay, and to this I have to write 1/2. 1/2 of this. Now, how to imagine this? You have to draw the characteristic points, and you have to depict all these points here. To this end, let us make a table. X u of xt, t less than 1/2. So we have the characteristic points minus 1 minus t, minus 1 minus t, minus 1 plus t, minus t, t, 1 minus t, one plus t. And let us see what we have. Here we have 0. Here we have at the point minus 1 plus t, minus 1 plus t, plus t, it is 2t, divided by 2t. Here at the point minus t, minus 2 minus 2t, 1 minus t. At the point t, it is 2 minus 1 minus t. Yes, I have to multiply. Now, at the point 1 minus t, 1 minus t, 2 minus 2 plus 2t, t, 1/2 here. And here it is t, and here when x equals 1 plus t minus 1 plus t is 0. Okay, let me draw it. So the point 1 minus 1, so it is 1 plus t, 1 minus t, minus 1 minus t, minus 1 plus t, minus t, t. So here we have these points. So t, 1 minus t, 1 plus t, minus t, minus 1 plus t, minus 1 minus t. So here we have 0. Here we have t. Yeah. In between the function is linear, of course. Here we have 1 minus t. Just a minute. T. Yes. It goes this. This is 1. This is 1. So this is 1 minus t. It is here. Yes. Here is also 1 minus t. Here it is t. Here it is 0. Now, if you do it accurately, we see that here the slope is 1/2, and here the slope is 1. Yeah, so we see this interesting picture. When t equals 0, so let us draw the first frames of the movie. When t is 0, we have this. When t is positive but small, we see the following thing. Here we have a flat piece, so it becomes lower. And here we have this piece. So you see what appears, how the solution evolves. Then we have just a minute. It is it grows, they meet in between. We have this picture. Yes. Next, it is a little bit tedious to draw it all. Next will be the following. The following thing. We'll have this picture. Yes. Here we'll see depression. And when t becomes more than 1, just a minute, let me jump to this case. Then f of x minus 1 is this, fx plus 1 is this, no, and this is solution divided by 2. And then for larger t, higher t, we'll have this picture. We'll have two hills which are moving left and right. Yes, so this here is the initial part of their development. Here the further development. Yes, and this is the final stage of this development. So they finally will have two copies of initial condition divided by 2, which are moving apart. Whew. I think something like this will constitute a sort of small project, which I will assign you in place of the midterm. I don't like midterm, but I prefer some project like this. So you see here we require some tedious and accurate work. Okay, for now let me finish, and next week we'll continue on at a more theoretical level. So for now, have a good time, bye.